Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 1208, get equal substrings within budget. This is a medium difficulty Leetcode problem, and we're given a problem description over here, where we're told that we want to change s to t, and changing the ith character of s to the ith character of t costs the absolute difference between the ASCII values of those characters. And we want to return the maximum length of a substring of s that can be changed to be the same as the corresponding substring of t with a cost less than or equal to max cost, which is provided to us. So let's actually look at an example. In this example, we have a, b, c, d, and we have t, which is b, c, d, f, and the max cost is 3, and a, b, c can be changed to b, c, d, which corresponds to the substring in the substring t. So the substring that we've made from S, or that we've derived from S, can also be found at the same positions, or the same indexes in T. So ABC of S can change to BCD, and the cost is 3. So the cost is the absolute difference between the ASCII values. And actually, let's actually look at this with a bit of a analysis. So let's say we have A, B, C, D. We want B, C, D, F, B, C, D, F. Okay. So we know that we want to compare A and B, B and C, and so on and so forth. But every time we make a conversion, like we go from A, B, C to B, C, D, we incur a cost. And that cost is the absolute difference. That's the absolute difference of the ASCII values of A minus B. And that cost is subtracted from our maximum cost that we're given until we go over that cost, and then we need to do something about that. And normally, with this kind of problem, we want to then choose another substring if it gets to that. So let's actually look at an example of how we can actually solve this. And how would we be looking to solve this? Well, one of the best ways we can do this is do a bit of pre-computation. So let's actually first pre-compute the differences. So let's say this is 1, 1, 1, and 2. So these are the differences, the absolute differences between the ASCII values of these of each character in both strings respectively. So what we can do now is, well, there's a couple of things we can do, but from a brute force perspective, we can start from 1, then say, let's create our substrings, and then once we've started from the first element, then we can go to the next element. And this is a kind of a brute force approach we can make to finding a substring that can be changed to the same corresponding substring with a cost that's less than or equal to the maximum cost. But brute force is not an optimal solution. It's not what interviewers are looking for. It's not the most optimal solution to solve this problem. What is a more optimal solution, and you might have already spotted this, is using a sliding window technique. It's kind of confusing once you're looking at string and character values, but once you look at it from a numerical point of view, you can see that it's quite easy to solve, and it's actually quite intuitive. And so just like we were doing with brute force, instead of having a brute force, we have a sliding window that we expand, and every time we get to, let's say we get to a number which causes our cost to be greater than the maximum cost, well, then we shrink our window. So we'll keep shrinking our window until we get to a smaller substring that meets the required condition. So that is the way we want to solve this problem today, guys. It's using a sliding window technique. Actually, let's get into coding this up. So remember the key word is really pre-computation, but we don't have to pre-compute. It's just a better paradigm for understanding how we're going to solve this problem. Convert all those characters into numerical values, and then just do a sliding window over them like you would with any other sliding window problem. So the first thing we want to do is set a result variable equal to 0 and a left pointer equal to 0, and we're going to have a cost. We can call it accumulator. Actually, no, we'll just call it a cost to make it easy. And the next thing we want to do is say for r in range of length s, let's increase the cost by the absolute values of the ASCII, or the absolute value of the ASCII value subtracted from each other. So cost plus equals absolute value board SR minus board S of TR. That's what we want. And when are we going to actually shift our left pointer? Well, whenever we get to a cost which is greater, so while maximum cost, or sorry, while cost is greater than the maximum cost, well, we've exceeded the cost that we are allowed, we've exceeded the threshold, so we want to now increment our left pointer, we want to shrink our sliding window. But before we do that, we also want to decrement that value from our cost. So we want to say, let's subtract from the cost, and instead of SR and TR, it's going to be SL and TL. And then result is going to be equal to the maximum of what the result currently is. Otherwise, it's going to be the size of the sliding window we have so far. And then we're just simply going to return the result. So let's submit our code, check it passes all test cases. And we have an issue. Where is my parenthesis error? Okay. That is a classic syntactical mistake. And we see that we pass all 37 test cases for this problem. So the time complexity for this problem, guys, is, if I can actually draw properly, it's going to be big O of n for time, and space is going to be big O of 1, because we're only using a couple of auxiliary variables. So I hope this video made sense, guys. Really, to understand this problem, it's to understand that we want to first pre-compute values, convert them into their numerical counterparts, and then actually use a sliding window technique on them, and then that makes the whole problem a lot easier to understand. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.